Lesson 8.1 is adding and subtracting polynomials. In this section, you will learn to write polynomials in standard form, as well as add and subtract polynomials. So, some vocabulary: polynomial, binomial, trinomial, degree of a monomial, degree of a polynomial, standard form of a polynomial, and leading coefficient. All right. So, state whether the expression is a polynomial. If it is a polynomial, identify it as a monomial, binomial, or trinomial. So, in this problem here that we have here, a polynomial needs to have all positive exponents and no exponents in the denominator. Not in denominator. Okay, so for this one, my exponent on the x is technically, there's a 1 there, so it's positive, and then this one just doesn't. So this one, yes. Okay, and this one is, because there's two terms, so a term is separated by the plus or minus. So there's two terms in this, so mono, that's 1, bi means 2, and tri, that means 3. So in this case, there's two terms, so this means it's a binomial. Okay, the next one. This one is a polynomial because it has all positive exponents, and I don't have any variables in the denominator. So this one is also, yes, polynomial. And this one, because it has 3 terms separating by plus or minus, there's 3 things, that is a trinomial. Okay, this next one, because of that d to the 4th in the denominator, that's a exponent in the denominator, that's not okay. So this one is no. Exponent, or sorry, variable. In denominator. That's the reason it's not, okay? And so you can't really say what this is, but it is a binomial. So then this one is a polynomial, right? Because we don't have any negatives, and we don't have anything in the denominator, so this one is yes. And then this makes this a monomial, because it doesn't have any plus or minus, so it's just one term, mono. Okay, if you want to write a polynomial in standard form goes from powers. You look at the powers, and they go from increasing or decreasing from greatest to least. So this one has an exponent of 1, this one 2, and this one 6. So the greatest one is the first term, and I take the whole thing. So whatever's in front of it, it was plus that whole thing. It's a positive 3x to the 6th. Then the next highest power is this 2. So it's going to be, this is technically like a positive there. So it's going to be plus 9x squared. And then my last one is this minus 4x. So this is standard form. Once you have a number written in standard form, or a polynomial in standard form, then they want you to find the leading coefficient. The leading coefficient is the number that's in front of the highest, the variable with the highest power. So in this case, the leading coefficient is 3. Just for example, if I had x squared plus 7x plus 5, in this case, there's technically a 1 there. So the number at the highest power is 2, so then the number, the coefficient in that, is the leading coefficient is going to be 1. So if there's nothing there, it's 1. Okay? All right, so if I want to write this in standard form and identify the leading coefficient, when I have 2 variables, I add all like the exponents for both of them. So this one would be like 2. This one would be like 3, because there's 1x and 1y to make a total of 2. This one, there's 1x and 2 y's to make a total of 3. This one would be 1, and this would be 0. So this is the order I want to put them in. I want to start with 8xy squared, and then go to 6xy, then 5y, and then plus 12. So that's standard form, and then once you're in standard form, is that first number, and that's 8. Okay, if I want to add polynomials, I want to combine like terms. So in this case, I'm just going to start by rewriting this without the parentheses because they're not actually needed. Okay, and then to do this, I want to combine like terms. Here I have 7y and 5y. So that makes a total of 12y squared. So 7y squared, 5y squared makes 12y squared. Then the next, I have 2y and negative 4y, which makes a total of negative 2y. If you add those together, negative 4 and 2 is negative 2. And then you want to do your constants. So we have negative 3 and 2, and that makes negative 1. So my final answer is minus 2y minus 1. Okay. If I were to do this one, again, those parentheses aren't really needed, so we're just going to start. So I have 4x squared and negative 7x squared makes a negative 3x squared. And then I have negative 2x and 3x makes a positive x. And then my constants, negative 9 and 7 makes negative 2. So this would be my combination of them. And generally, we always want to start with the highest powers. So we started with x squared, and then we went to the x, and then we went to the one that didn't have any variable. Okay, so when you're subtracting polynomials, you just want to be sure that you are distributing correctly. Negative goes to each of these things here. So the first thing I want to do is rewrite this distributing that negative. So I get 6y squared plus 8y to the fourth minus 5y minus 9y to the fourth plus 7y, multiplying that negative, and minus 2y squared. Once I've done that, now I can go through and combine. So always be careful with negatives. So starting with the highest power, I have 8y to the fourth and negative 9y to the fourth. So that's going to make a total of negative y to the fourth. Then my next highest power is my squares. So I have 6 and negative 2, which makes a total of 4y squared. And then my just straight up y's, 5 and 7, to give me 2y. And then that would be your polynomial when you subtract those two. Okay, so again, we just want to start by rewriting. So this is 6n squared plus 11n cubed plus 2n minus 4n plus 3 minus 5n squared. Okay, so once I start with the highest power, and my highest power is 11n cubed, and there is no other cubed. So I just do 11n cubed. I don't add or subtract anything to it. My next highest power, so I have 6n squared and negative 5n squared to make a total of 1n squared. And then I have 2 and negative 4, which makes negative 2n. And then I just have my constant. And then that would be your new polynomial once you subtract those two. Okay. Example 5. The total amount of toy sales, T, in billions of dollars consists of two groups, sales of video games, V, and sales of traditional toys, R. In recent years, the sales of traditional toys and total sales could be modeled by the following equations, where N is the number of years since 2000. Okay, so R is that thingy there, and T is that thingy. So we want to write an equation that represents the sales of video games V. So we have two types, the total amount of toy sales and the total amount of consists of two group sales of video games and sales of traditional toys are. Okay, so total it consists of, basically we want to take the total and take out the amount of video games. So I want to do, in order to solve, T minus R. So the total number of games minus the traditional toys, and that's going to give me how many video games there are. So if I'm doing that, I'm going to put in my T, which is 0.45 n cubed, minus 1.85 n squared plus 4.4 n plus 22.6. And I'm subtracting all of r. So remember, it's subtracting this entire thing. So I'm putting all of it in parentheses. Okay, so when I do this, I want to distribute that negative all the way through here. So this is going to be 0.45 n cubed minus 1.85 n squared plus 4.4 n plus 22.6 minus 0.46 n cubed plus 1.9 n squared minus 3n and minus 19, combining like terms. So the 0.3s, or to the power of 3, we have 0.45, and then we're subtracting 0.46. So that's going to be negative 0.1 n cubed. My squared is negative 1.85, and then plus 1.9. So I get 0.5 n squared. My n's, I have 4.4, and then minus 3 is going to be 1.4. So it's going to be plus 1.4 n. And then my constants, I have 22.6, and then minus 19. So I get 3.6. So plus 3.6. And then this is my v. Okay. If I want to use that equation to predict the amount of video game sales in the year 2009, n is the number of years since 2000. So I'm putting in 9 for n into this equation that I just found. So 9 cubed times negative 0.1, that's negative 72.9. 81 times 5, 40.5. 9 times 1.4 is 12.6, and plus 36. So I'm just going to put, or 3.6, put all of that into the calculator. So plus 3.6 plus 40.5 this one here, this should have been 7.29, right? Because this, when I did 4.5, this should have been 0.01 right there. Anyway, so when you do this, negative 7.29 plus 40.5 plus 12.6 plus 3.6, you're going to get a total of $49.41. So $49.41 were spent on video games. Well, anyways. So that is the end of this section. Okay.